Hello, it's Neil doing a cracking code interview question for the trees and graphs section, which is you check if a binary search tree is valid or not. So it's return a Boolean to check to see if a binary search tree is valid or not. So it just kind of goes to your clarification question of what is a binary search tree, which is pretty much that all left subtree values are less than the node that you're given it, and all right subtrees are greater than. So like to illustrate that, here's a binary search tree. Say you're given 50, that everything left in this left subtree should be less than that. So like if 31 had a right value of like say 55, 55 is under the subset of children of 50, and that's 55 is greater than 50, so that would be invalid. Yeah, that's kind of it. So it's yeah, so initially how in order to figure that out, you have to traverse the tree, and when you traverse the tree, you can do breadth first, depth first search, in order, post order, pre-order traversals. I think what I did is just a what did I do? I did a breadth first search, breadth search, or you can do depth search too. But essentially, what you would do is you just traverse it, and then you pass in recursively traverse it, and then you just pass in another two values of minimum and maximum of what each node can and can't be. So when you get to this case of 31, it'll also pass in, it'll have prior knowledge that, hey, the max can be 50, and the minimum can has to be between 25 and 50. So this value can be anywhere between those two. So if you have a greater child, it has to be less than 25. So at 31, if you have a right child, it has to be less than 50. Or anything up, yeah, less than 50. And then anything, and it has to be greater than 25 if it's a left child. Right, so it has to be between 31 and 25. Now that's kind of what you do. You just always do recursively go through, iteratively go through, just recursively go through the tree and then pass along the max and min values. Yeah, so like examples on node 25, we would call the minimum it can be is like some. I did a really small negative number. Also, you can put null in here and just do checks if it's null, but the max can be 50. And if you go to 75, the min has to be 75, and then it can be anything less than max. So here's just your node class. Here's my first attempt at it, but I had it. So you just have your is a valid binary search tree. It takes in a node and some like infinity, negative infinity from min to max. They can be null, and you just have to put the null checks in there too. If the node is none, then that means yeah, that's a true binary search tree. And then you just gotta check that the node is less than the min, and the values. So they use the fail case. If your value is less than the minimum, that's not good. Or if the value is bigger than the max, then you can return false. If not, then you just you do the traversal and you pass in the new values. So when you go left, you have to update the max. So we're traversing to the left, and we're passing in the min as the same, and then we're updating the new max to be the node value. And then the opposite inverse, and when you go right, you have to update the minimum with the new node value. So then you go right, and it just passes in the max. I did this, but then I totally forgot how to exit. It was running it correctly, but it wasn't exiting when it did find a false case. That's because I forgot to. It's kind of a weird thing, tricky thing about recursion is when you recurse, you can also check it against a value. So like here's the correct version, which is these two lines are pretty much the same. But what I missed is if you recursively call it like we do and update the values, which I had, but you have to say if that recursive call was false or if you recurse on the left and it returned false, or if you recurse to the right and it returned false, then you have to return false. If you keep doing that and you never return these two falses, then you can just return true, and then you traverse the whole binary search tree and you return true. So yeah, this is the tricky part. So just maybe for me to walk through this again. Yeah, so you're making a recursive call to the left, and that if those return false, then you have to return false to the main recursive function. Because that's like, why can't you just because I thought the exit case would just be this for all cases, but it gets there until a node equals none. So you recurse left or right on a leaf, and it returns true. It's just kind of, I need to understand recursive call and the call stack better, but essentially that's kind of the case though, or the generally is passing in the min and the max along with the recursive call. So when you do recursive traversals of graphs, you can also pass along updated data to it and compare that and do other funky things with it. You just can pass in more auxiliary parameters or arguments. So yeah, just to test it, here I implemented this tree, so this should return true. I built it up here. So let's just try it out here. What do I call this? Is it valid bst.py. Oh, that's my original. So as you can see, it never really exits. It just returns none, which is not good. But it kind of does the logic, right? It just doesn't exit. So that returns true because it's a valid one. Then let's here's an invalid node. So where can we put that? So let's change 60 to 49 because 49 is less than 50. So 75, node 75 left. If you do this to node 49, now the child of 75 is going to be 49. So this should return false. So there you have it. So that's that. And kind of, yeah, like the takeaway key for me is to learn about recursion, and you can check a recursive call to equal false too. It's kind of weird. So it's like at some point this line 55 is getting checked to line 57, which is kind of weird. And another instance of it. So, and yeah, then you can pass along auxiliary parameters in a recursive function.